Today we are trying to get the volume of solids. When we go to find volume of solids, we are still going to set up an integral. This time though, we are going to take, in this case, just the yellow region. We're going to be revolving it around the x-axis. And the key to how you revolve it, we've already talked about that revolving is going to give you some form of a circle, either a solid disk or a washer. Whichever axis you're going around, that's pretty much the axis that you want to cut so that you can make sure that you do get those circular regions. We're going around the x-axis. That does mean that we are going to be cutting using dx. The first thing I want to do is kind of draw you a representation of what this solid is going to look like. Since this is 2 dimensions that I'm working with in sketching, I'm going to take this black curve right here and I'm going to reflect it over the axis that I want to revolve around. So the x-axis is going across. I'm going to reflect down here. I can pick up my highlighter. Looking at that yellow section now, if I have indeed rotated, some of you it will help if we do a little circular thing here so you can kind of imagine what that revolving is going to give you. In my mind, I kind of see a dome shape that's turned over on its side. Can you all kind of see that? So when you make your slices here, if we are going around the x-axis, if I cut perpendicular to that, this would be like a representative slice for me there. Can you see the circles coming out? Okay. From there, will you agree with me that this is going to be a solid disc this time, each time I slice that dome shape? Right? In that case, that lets me know that we're going to set this up using the disc method. Now, since we did say dx is the axis that we are cutting here, then I want to make sure that my x bounds here are representing what part of that x-axis is in that yellow shading. So what would those be? And then we want to make sure that we have the pi, and then we want the radius squared since it is a disk. And that radius, when you go to draw it, this is just a suggestion to help you make sure that you have a good drawing. I want to draw the radius from where I rotate, which in this case is the x-axis, and I want to make sure that I draw toward the original curve, not the reflected curve, but the original curve, which in this case means I need to draw upward. Doing that does hit one ordered pair on that curve, and that point would change as the slice moved. So that is an XY ordered pair on that curve. And that red radius, does that have to do with the X or the Y value? Y. So that tells me the radius is a Y value on the curve. I still can't place that in the calculator yet because my variables are not in agreement. So I need to go back, look at my equation, which is y equals 5 sine x. And since I need y to be squared, what would I put instead of y squared? 5 sine x, but that needs to be quantity squared. So what is the 5 going to become? 25. Okay, so we got 0 to pi over 2. We got pi, and then 25, and then sine also needs to be squared. Now, there's nothing wrong with that answer. You can put it into the calculator. It'll spit out a nice decimal for you. Some students, they don't like having the pi inside when they're doing Math 9 in the calculator. It's very common for my students in the past to have put the pi out in front and then 0 to pi over 2, and then just put the 25 sine squared in the calculator. And then at the very end, they multiply by pi. If you prefer to do that, or if you want to put the pi in the integral with Math 9, it will not matter. Get the same answer either way. Questions? All right, next, example 2. Still going to be the same picture, but this line, instead of the yellow region, we want the green region to be rotated around the x-axis.
Same thing, just
Same thing except the outside. That's a good way of thinking of it. So that same curve, I'm going to reflect it over the x-axis, but with the green section, I have to also think about horizontal part here. So I've got my little green highlighter. And that is what I end up with. It helps to draw the little circular section out here so you remember that that is rotated.
Are you finding both the greens or just the one on the bottom?
Just, I'm finding the green solid that I end up with. So imagine that I've got that horizontal line on the top is rotating, which is pretty much going to give me a cylinder. And then you've got that dome that's being taken out of it.
So you're just, it's a disc.
Okay, so this one's not a solid disc. The yellow would be the disc, but the disc is what's coming out. So you get washers on this. So you're going to have, there's your outer circle, and then there's your inner circle. Y'all see that? Okay, so on this one, when you're setting it up with washers, hopefully you can see the two radius values showing up there. So I'm going to put pi on the outside. On this one, you could put it on the inside if you prefer. Which axis is it that we're cutting? All right, but which axis? Is it the X or the Y axis? Let's get circles. X. There you go. If you're rotating around the X, then you're going to be cutting the X. That means the X is going to go out here. Yeah, it says for circles, the formula for a circle area is pi r squared. And on a washer, it's pi big R squared minus pi little r squared. So I just do the pi out in front so I don't have to write it twice. Okay? Now, from there, got to get big radius squared minus little radius squared. What would my bounds be? Right, now, the big radius on this one, again, go from where you rotate to the furthest out part of that shading, which in this case carries me all the way out to that horizontal line. No matter where I did my representative red slice, notice it would still go that same distance. Any questions there? How long is that radius? 5. Put 5 squared. Now, the inner radius, smaller radius, from here, that is going to go up and touch this black curve, and depending upon where we are on that black curve, notice that would be a different length. So that blue segment that I just drew, that has to do with the ordered pair that's on that curve, x, y. Is that the x or the y distance? Right, so then that right there is going to be y for its radius. And last thing I want to do is, instead of y squared, I want to go back and plug in what y is equal to. So we'll clean this up. Keep the pi out in front. 0 pi over 2. You can either leave that 5 squared or go ahead and clean that up to 25. And instead of y squared, what are we going to put? Any questions? Okay, next one, same picture again, but this time we're rotating a little differently. I'm going to take the yellow section around x equals pi over 2. See if you can sketch what that will look like. X equals pi over 2. That's what I've got to rotate around. That's going to actually be over here. When I rotate over that, I'm going to reflect it for my purposes up here. And it is just the yellow section I want to highlight. which means you can pretty much ignore the green now, guys. If I rotate that yellow section in that way, am I going and make my cuts? First of all, can you tell me what axis I need to put? Is it dx or dy? Dy. All right, well, you are correct. However, what we had said on the last examples is it was dx if you were going around x, and dy if you were going around y. Well, if I'm going around x equals pi over 2, x equals pi over 2 is not the x or the y axis. Will you agree? However, it is a vertical line. Which axis is also vertical? Y. So if you're going around something parallel to the y-axis, that means you cut dy. Whereas if you're going around something that is parallel to the x-axis, then you're going to have dx. Make sense? All right, now, can you tell me what my bounds would be? 0 to 5, good. And if you make these slices, if I did just a representative slice of the yellow section, am I going to get discs or washers?
Yes.
You will get discs. This is pretty much like a regular dome.
But if you're doing green,
if we were doing green, then we would have had washers because you would have had a section taken out. So good question. All right, so on this, if it is indeed discs, that tells me I can put pi out in front or pi first, and then I just need the regular radius to be squared, the single radius. Drawing in this radius, you have to be careful with. Remember to start from where you rotate and draw toward the original curve, which means I go which direction? Left. Very good. Now that does touch an XY ordered pair on that black curve. I drew that going across, which means we would expect that that red distance has to do with which variable? X. However, that red distance is not exactly X. Where is X? Down would have been a Y value. It would be down on the x-axis. What does that mean? What do you think? Not 1/2 of x, not necessarily, because notice if my slice had been further up here,
it's 2x.
then not 2x. Sweet. All right. Brian was actually on the right track whenever he said down on the x-axis. You agree with him that if you come over this distance right here, that is x? Doesn't that mean this up here is the same as that? Oh, so it's x minus. How do you get the red? Pi over 2. Pi over 2 goes all the way over here. Minus whatever x is going to be what the red section is.
You would just use the pi over 2 and say x is all the way on the bottom.
X is down here. Okay? But in order to get the red radius, okay, listen to this. You will have to do subtraction for the radius. Anytime your point right there, the radius does not connect to an axis. If it doesn't connect to the y-axis, or if it didn't connect to the x-axis. If I needed the radius up here, for instance, that's not going to connect to the x-axis. I'm going to have to do subtraction. Here, this does not connect to the y-axis. I'm going to have to do the subtraction.
Okay. You say have to do subtraction if it does not connect to x.
Okay, correct. All right, so on here, that is going to be the pi over 2 minus x, and then that's quantity squared because we've got to have the radius squared. Now, I can't put that in the calculator yet because notice my variables are not in agreement. So somehow or other, you're going to have to get x by itself. Your equation was y equals 5 sine x. How do we get x alone?
Inverse sine.
Inverse sine. There you go. Yep. Sine by itself first. So y over 5 would have been sine x. So that means x would have been sine inverse of y over 5. So my final setup, pi pi 0 to 5 pi over 2 minus sine inverse y over 5 squared and then dy.
Why is it sine inverse of y over 5? Sorry.
Well, you have to get x alone. So
Oh, you divided by 5.
divide by 5 first and then take the inverse. All right, next one. This time I did not give you the function. On this one, you need to be able to interpret a written description of the graph and then figure out what the shaded region would have been, so to speak, and then imagine how that would rotate. So underneath here, I've got it kind of sketched out for us, but I want you to try it. If you have the first quadrant of that parabola, hopefully you've got something sketched on your paper that looks about like this, which means this ordered pair up here is important to me. What ordered pair would that be? 525. Very good. All right, now that kind of divides this curve up into two sections. You could have shaded it green and yellow like I did those last ones, or you could think of that as the upper section and the lower section. Which section is it, upper or lower, that we need here? Upper. So I'm going to go ahead and kind of shade that in, which means I need to rotate that around y equals 25. Okay, y equals 25, where's that? All right, horizontal, right up here on the top. So that means I'm going to reflect up this direction. You agree we got a sideways dome looking thing again? So which axis do I put, dx or dy? Dx. I went around something that was parallel to the x-axis, so we're going to have dx on our integral. Is this discs or washers? Discs. Very good. So if it's discs, I want pi, and then I need a single radius to be squared. What about my bounds?
0 to 5.
0 to 5. And then in getting the radius, let's see here. I'll draw my slice going about here. I'm going to go from where I rotate to the original curve, which means I need to draw it which way?
Down.
Down.
You have to do subtraction.
Okay, and why do we do subtraction there, Preston? Very good. That does not touch the x or y axis. Yes.
How did you find out that's dx?
How did I find out it's dx?
Yeah.
Okay. Y equals 25 is a horizontal line,
Oh,
and the axis that's horizontal is x.
okay.
Good question. All right, now, Preston's already told us that this needs to do subtraction. All right, let's see. Are we going to be subtracting an x or a y? A y, because notice y would have been down here. So that radius is actually going to be what minus y? 25 minus y. There we go. And then instead of y, what am I going to put in? X squared. So we'll keep the pi out front. 0 to 5, 25 minus x squared, and quantity squared, because that was radius, 25 minus x squared. Questions?
What
Yes, sir?
about, how did you know which part to shade? Why didn't you shade the outside rather than
Okay,
the inside?
because it was this right here. That's the parabola. So I knew that I had to have this portion right here. The y-axis meant I had to have this portion.
These are just the restrictions.
And then it said it had to go from 0 to 5. So that meant start here and go to that ordered pair right there. So that had to be the shaded region in here. Yes, ma'am?
That it's on outside axis instead of y-axis.
Then you would have done the bottom portion. Yes. All right, here's one more. And on this one, I'll give you a hint. You need this ordered pair in order to get this one. I want you to see if you can draw it, rotate it, and get the integral set up for me, please. Hopefully your picture looks something like this. It's just the green that is rotated. Out like that. Do you all see the white space?
Yeah.
So definitely you do have washers on this one. Fine. Did you all put dx or dy? Should be dy. So you're going around the y-axis, so it should be dy. So when I make my slices, they're going to go this direction. You see the white space there, which does mean you're going to have the washers. What are the bounds? Very good, 0 to 32. So that was that ordered pair I told you to find. If you go out the 4 is the x at that ordered pair, and the 32 is the y, because you're trying to do the square root of 4 to the 5th. I like to think of that as the square root of 4 raised to the 5th myself. Be 2 to the 5th. All right, now I need the big radius squared minus the little radius squared. What would the big radius be? It's 4, like that one. The little radius. All right, when I draw that in, does that connect to an axis? Does this radius right here connect to an axis? Yes, it does. So there, I don't have to worry about subtraction. What variable is it? X. So we'll put X right here. Which poses a little bit of a concern. Students know that they need to get the x squared to be in terms of y, but if your equation was y equals square root of x to the 5th, they're not excited about getting x to be squared. So let's think about writing this another way. That's the same thing as x to the 2/5, but 5/2. All right, which means x would have equaled y to the 2/5. So what is x squared going to equal? Y to the 4/5. So that's all you got to do is plug that in back up there. So we'll have.
Multiply by those raise the squares.
Yes. 0 to 32. Instead of 4 squared, you can leave it 4 squared or do 16, and then y to the 4/5 here. Any questions? Given this FRQ for the AP exam, similar question. If I have to set up an integral in part C to find the volume of a solid formed by rotating that shaded yellow region around the x-axis, that means you're going to end up with a solid that looks kind of like that. Okay? Do you see white space? Okay? White space is important because what are we getting on this one? Washers. So we're going to set this one up using washers. So on my integral, I'll put pi out in front. What are the bounds?
A and B.
A and B. And those we found last week. So I need now my big radius squared minus my little radius squared. Which axis?
Y.
You're going around the x, so it better be dx here. All right, now I need the outer radius, the big radius. It's a y value. I like that you said a y value. Earlier they told me the y value. Why do I like a y value better than the y value? There's more than one. Do you all see that? Aren't there two y functions up here? So which y value is it that is my outer radius? The y value for g of x, because notice that would be the parabola that you're going out the most with. Okay, so you're going to have g of x is going to be squared for the outer radius, and then the inner radius would be, or the little radius, e to the x. So that's the f of x one. All right, so for your final way to write this one, you can have pi, and you go from a to b. And then on the first one, for the g of x, you do the parabola, 6 minus